Hello guys, here Gabby again. Today we are going to talk about a little bit about design patterns in the .NET Microservices ecosystem. We know that design patterns are one of the most misunderstood topics in software engineering. Some teams use none, others use all of them everywhere. Both approaches lead to problems, as in life. Perhaps we try to reach for an equilibrium. So either the code becomes rigid and ad hoc, or it becomes over-engineered and unreadable. So I will try briefly from my approach in this video to explain what design patterns could be and how can we classify them, and most importantly, which ones we could use and why. No pattern worship, no academic theory, just practical decisions. So I hope it helps to you if you are reaching out or passing by here by this video. So here is the key idea. Design patterns are not goals, and they are tools. We use the patterns as a tool to, to resolve all the problems that we have. Not all the problems, but if we think about it, if we look uh, as a microservice in scope, we are already seeing patterns. Okay, so if we apply them blindly, the system will be worse. It's not going to be better, and we have a default for the system, for the solution that we are applying, that the design patterns are proven solutions to recurring design problems. Okay, there are problems of the design of the system, of the problem that we are trying to resolve, and there are design patterns that help us to achieve that goal, to resolve the design patterns of the architecture, of the initial architecture of the solution. Okay, the design patterns are not libraries, are not frameworks.
Battery low.
They are ways of structuring code. Okay, they give names to ideas that experienced engineers already applied intuitively. So it could happen that perhaps in an interview you talk with your interviewer and you explain all what you did in your microservices, in your past work, in your past project, and you inherently, intuitively applied these design patterns, but you don't know the definition. So, what design patterns really are? Design patterns, pardon, sorry. Um, these design patterns help teams to communicate design decisions. We avoid reinventing the wheel, and we recognize structure in complex systems, because in complex systems we try to be the more concise as possible, with little upgrades and improvements. We can escalate as a compound interest a better system. Choosing design patterns is like try to communicate ideas of what we are trying to achieve, and not reinventing the wheel. So we know what things can be done, what things can we use, and we apply them. We, for example, when we are studying data structures, algorithmic complexity, and so on, eventually when we read the problems, when we see them, we we do not memorize, for example, in our life, oh, this is BFF, this is Kruskal, this is Dijkstra. No, we do not recitate from memory those algorithms. For example, we read the problem, uh, um, we then see, hey, this problem can be resolved with this technique, with this algorithm and so on. And well, in complex system, in the work, uh, um, that 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 could happen. So as a general classification, the design patterns are usually grouped in three big categories: creational patterns, structural patterns, and behavioral patterns. Okay, the creational patterns, they solve how the objects are created. The structural patterns, they solve how objects are connected, and the behavioral patterns, they solve how objects interact each other. Okay, so we have uh, patterns to create the object, patterns to connect the object, y patterns to interact. Okay, because we have objects that can be created and we have patterns to create those objects, and then we could have a multiple object and we need to communicate with them, we need to connect them. That connection is one of the patterns, but the interaction is other thing. The classification matters because in microservices we do not need them all. Okay, so a quick overview of the patterns by category. The creational patterns, they deal with object creation. As for example, we could have, remember, the creational patterns resides on the creation of the object. We can have a factory or abstract factory, builder or singleton. For example, the factory or abstract factory, we can say briefly we have a result pattern, a result class that resides on the domain as an entity that bubbles up through all the stack of the application, and the result could have states that is a result of success, a result of failure, a result of unauthorized. We emulate HTTP responses and so on. We could build with a factory pattern a factory in the generic result class, or the base class for one instance, and so on. But so in microservices, most object creation is already handled by the dependency injection, so we rarely need heavy creational patterns. Okay, I just said only one example. On the other hand, with structural patterns, they deal with object composition and boundaries. Okay, I repeat, they deal with object composition and boundaries. We have, for example, some patterns like adapter, facade, decorator, and proxy. These are extremely common in real system: the adapter, the facade, the decorator, and the proxy. On the other hand, with behavioral patterns, they deal with the communication and flows in the system through, for example, the layers of our application. We already talked about in other videos about um, um, uh, the CQRS pattern. That is also another thing that we use command and queries with segregation of responsibilities, and that helps to communicate through the API layer, the application layer, and so on. And we can use it with a library, for example, the Mediator. We could also have a strategy pattern as a behavior, because we can use polymorphism with an abstraction of an implementation or of a contract of a payment gateway, and that abstraction that resides on the application layer defines what must be done, but implementation at runtime can have multiple implementations, and there we can use a strategy to decide what to do, for example. Okay, so which ones I usually use? I use the mediator, that it helps to decouples the API, the use cases, the internal dependencies, and the API does not call services directly. Okay, it sends a request and the mediator routes it. Okay, this keeps the orchestration clean and isolated. Okay, it decouples what is the API with the use cases and the internal dependencies. That's very, very important. Along with that, the command. We talked about the CQRS. Remember, the command with CQRS commands are a direct application of the command pattern. A command encapsulates an action, its data, its intent. Okay? This lets us orchestrate workflows without mixing responsibilities or logic layers. The strategy pattern. The strategy pattern, we use it when the behavior can vary without changing the main flow. Instead of large if-else blocks, we use interchangeable implementations. Typical examples: calculation strategies, validation strategies, or external provider selection, as I said before, with a payment gateway. For example, the flow stays stable and the behavior changes. For example, the selection of the provider. The adapter is critical when we are integrating an external system. We never let the provider model leaks into our domain. Instead, the adapter translates external APIs into our internal DTOs and models. The gateways act as adapters that protects the domain from external chaos. One common pattern is the repository pattern. The repository pattern abstracts the persistence. The application never talks to the entity framework core directly. Where we use it? When we are trying to access data with the data access. What it gives us? The ability to change data access strategy, to test without a real database. It's centralized and optimized queries. And for example, we can have a abstractions or interfaces like iCustomer repository, iPayment repository, and so on. Sorry for the delay. We're going to continue. We are back with the other series. Sorry for the delay. We can talk about the unit of work pattern that coordinates changes and defines the commit boundary. Entity framework core already implements via DB context. We don't reinvent it, we respect it. Then we have the facade that for example, the application acts itself as a facade. It hides the domain complexity and the infrastructure details. It's a facade. The consumers does not need to know how everything is resolved. So we could say that application itself it's a facade pattern. Okay, they interact with a simple surface. Chain of responsibility. We use this pattern in pipeline and middlewares. ASP.NET Core middleware pipeline is a chain of responsibility because yes, each middleware is sequential and it's important to know the chain of responsibility of all of them. It decides whether to continue, it can modify requests or responses. As final takeaways, Design patterns are tools, not trophies. They solve a real problem, they reduce coupling, and they increase clarity. We avoid them when they are complexity and they do not match the problem. So I hope this helps, and thank you for watching and have a nice day. Bye bye.